All right, we're going to talk about radicals and rational exponents. So first I want to talk about the parts of a radical sign. This right here is a radical sign. Wow. All right, actually, let's color that a little differently. That's a radical sign. And the way I think of a radical sign is like a house, okay? So the way I look at it is, like I said, it's like a house. So out here in front of the radical sign, I would call that as outside the house. All right, and let me see here. Let's pick a different color here. Pick a dark blue. And over here, we would call this inside the house. And then there's one more thing. And I would call this is known as the index or the root, which I would call this the wedge. So you'll hear me talk about this as a wedge a lot, but it's basically the index or the root. And another thing that I called inside the house is, well, the actual name for it is a radicand. So those are some of the information you need to know about the parts of a radical. All right. So what does all of this mean? So typically, you will see things like try that again. Like this. Let me try to draw that better. It's 3 in here. So what is that? This would be known as a cube root. Okay. If we notice that the index is a 3 because that's what is in the wedge. So the way I look at it is that we're going to look for triplets or 3 of a kind. Okay. In fact, I want to make this a little better. We'll call this the cube root. I'll put that underneath there. And let's move this a little bit closer here. Okay. So again, we identify that the index is 3. We know it's triplet, and we're looking for 3 of a kind. So what does that mean? So for example, if I had the cube root of 27, we can break 27 down to primes with a factor tree. And what we would have is we would have a cube root of 3 times 3 times 3. Okay. So since we have 3 threes, or 3 of a kind. Let's use this. Since we have 3 threes, then that means the answer is a 3. Okay? Meaning that if you guys remember, like for example in grade school, in order for you guys to go out to play, you would need to be in pairs or groups of 3 in order for you guys to go out to play. So since the 3s have a group of 3s, they get to go out to play. So there's a group of 3 that went out to play. So therefore, there's nobody left inside the house. So this 3 is outside the house. Let me give you guys another example. Let's say the cube root of 64. Okay. Well, cube root of 64 is actually the cube root of 2 times 2 times 2 times 2 times 2 times 2. Okay. So if you notice, we have a group of 2's. Let's try that again. And another group of 2. So what this would be is that there's a group of blue 2's that get to come out to play, and a group of red 2's that come out to play. So therefore, the cube root of 64 is 4. Okay. I can also take, let's do another example, a cube root of negative 64. Actually, let's change that number to, instead of 64, let's do negative 27. It'll be easier, because I can break this down to negative 3 times negative 3 times negative 3. So if you notice, there's a group of negative 3's, so the cube root of negative 27 is negative 3. All right. So what if we have something that did not have a number in the wedge? Like that. Well, this is called a square root. Where what we know is that the index, when there's nothing in the wedge, is a 2. So we're looking for pairs or 2 of a kind. All right. So for example, we can take the square root of 25. We'll break that down into primes. It'll be the square root of 5 times 5. So since there is a pair of 5 that can come out to play, so the answer of square root of 5 is just 5. If I had the square root of 81, that'd be 3 times 3 times 3 times 3. So what I have here is a pair of 3's that come out to play and a pair of 3's that come out to play. So what we have is that will equal to 9. Okay. But what if we had a square root of negative 25? Well, the problem here is that I can't find 2 numbers or a pair of numbers, same exact numbers, multiplied together, that would give me a negative 25. So in that case, this will not be a real number. okay? However, that's very different from if I said the negative square root of 25. Because what this is telling me is to find the square root of 25 first, just like if it was a parentheses, and then negating it. So this will actually be the negative square root of 5 times 5. So that would be a negative 5, okay? So similarly, with cube root and square root, if inside the wedge was a 4, okay? We don't have a special name for this. We just call this a fourth root, okay? So in that case, and anything after this or higher than a 4, we just call it the fifth root, the sixth root, or nth root, okay? So this right here, the index is a 4. So we're looking for 4 of a kind. All right. So for example, we could have the fourth root of 81. So what I know about 81 when I break it down is going to be 3 times 3 times 3 times 3. So there's a group, there's 4 of a kind of my 3's, okay? There's a group of 3's, so therefore the fourth root of 81 would be 3. I hope that makes sense. Or let's say the fourth root of 625. Well, 625 is 5 times 5 times 5 times 5. So therefore, it's going to equal to 5. Now, don't get me wrong. These are all so-called perfect cubes, perfect squares, and perfect fourth roots per se. And obviously, our world is not perfect. So let's talk about problems that you might have to simplify. That are not perfect, that we might actually have other things going on. So let's take a look here. For example, let's say I have the cube root of 250 x to the 10th, y to the 17th. Okay, so I said the cube root. So the first thing I identify is that this has an index of a 3. So we're looking for 3 of a kind. Okay, so that's number 1. Number 2, we're going to break everything down. We're going to break the numbers down. We're going to break down the x's and the y's that are inside the house and see who can find a group of 3 so they can come out the house to play. All right, so let's do this. Let's highlight my 250 here, make it red. So let's break down the 250 here. So if I was to break down 250, that's going to come down to 5 times 5 times 5 times 2. Now let's look at the 10. X to the 10th. Let's make that blue. So x to the 10th would be x times 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 x. All right, and let's look at the y to the 17th. Let's pick a different color here. Let's try green. All right, so this is going to be y times 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 y. That's 12 15, and 17. Okay, so those are the y's that are broken down. So let's do this here. So that's what's going to break down to y. That's what's going to break down to 250. And this is breaking down x to the 10th. All right. So again, I'm looking for 3 of a kind. So let's take a look here. If you look at the number 250, you notice that this right here is a group of 3. Right? And then over at the x's, you see that these are group of 3s, and the y's, those are the groups of 3s. So the question is, what's left over? So what's left over is going to be this 2, this x, and the y squared. Okay? So how do I break this down? So I'm looking at this going this way. I have a group of 5 that came out. Actually, you know what? Better yet, let's do it in colors. I have a group of 5 that came out. Right? At the x's, I have 3 groups of x's that came out. And if I look at the y's, I have 1, 2, 3, 4, 5. So 5 groups of y that came out. So who is left inside the house that cannot come out to play? The 2 cannot come out to play. The x cannot come out to play. And the y squared cannot come out to play. So hopefully you guys can see, maybe what I would do here as well is to show you that this is everything that was highlighted green on the left side, and then this is everything that's highlighted in yellow on the left hand side. Okay, so hopefully that will help. And this will show you that this is my answer. Okay. You want another example? Sure, we can do that. So example 2. So let's think here. How about if we did the same problem, but we're going to do it as a 4th root. So let's change this to, no, keep this to 250, x to the 10th, y to the 17th. But this is going to be the 4th root. Okay? So I'm going to break it down the same way. Say the 250 is red. Change that to blue. And change that to green. All right, so when we break this down, if you notice the difference of how I process or break down and list these numbers and these variables, I want you to see the difference here. So this is going to be 5 times 5 times 5 times 2. My x is going to be x times 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 x. And for my y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, and 17. So notice how up here, because the index is a 3, I kept in groups of 3s as I broke them down. Where over here, the index is a 4. So therefore, you notice my groups are now in 4s. All right. So when I go and say, okay, how many groups of 4s do I have? With the 250, I'll have a group of 4 of any number. So therefore, I can't let any of them go outside the house. They're all going to have to stay inside. But if you look at the X's, I have 2 groups there. The Y's, I have 1, 2, 3, 4 groups. So who has to stay inside the house? Here we go. These guys are going to have to stay inside the house, and inside the house. Okay? So let's write this out. So let's try it this way. So who gets to come out the house to play? So I have 2 groups of X's that can come out to play. And I have 4 groups of Y that can come out to play. And who stays inside the house? I have the 250, right, which is the 5 times 5 times 5 times 2. I have X squared, the 2X's right here is going to stay in. And I have a Y that has to stay inside the house. So then I draw, and call that the 4th root. So there is my answer. And that is all it is. All right, so that's how you would break them down. Now don't forget, just so you guys understand this, is that if I have 2 things, let's say 2 cube root of 3 times 4 cube root of 5. Okay, so in other words, what I gotta make sure in order for me to multiply these, I have to have the same root. Okay, so what this is going to equal to is going to be 8 times the cube root of 15. And your question might be, how did I get the 8? Well, the 8 is coming from the 2 times the 4, and that will give me the 8. Okay, and the 3 times 5 will give me the 15. Okie doke. So that can go both ways. So you can, when you multiply, it's the outside times outside, the inside times inside. So you can only multiply if you're both outside the house or if you're both inside the house. But you can't multiply if one of you guys are inside the house and one of you guys are outside the house. All right. So same thing happens with dividing. So let's say I have 6 cube root of 18 over 2 cube root of 3. Okay, so that is going to give you a 3 cube root of 6. Okay, same idea, outside with outside. So if I do this, so the 6 divided by 2 would give you the 3. Sorry about that. All right. The 18 divided by the 3 will give you the 6. Okay, so hopefully that will help. All right, so let's talk about rational exponents. Okay, rational exponents. So what rational exponent is saying is that I can change a radical, for example, the cube root of x to the 4th. I can change that to a rational exponent, meaning an exponent that's a fraction. So this can be converted to x raised to the 4/3. Okay, and you're probably going, well, where did you? Why the 4 there? Why the 3 there? Is there a proper thing to do to think about it that way? So here is the picture that I typically draw for the students, but here it is. So, let's look at pictures, right? So sometimes the pictures you have, of a landscape or a family photo or something, you'll have, grass. And you're wondering why I have a blank there. So sometimes you have grass, and then what you'll have is you'll have, a tree. And that tree, obviously, you got your leaves, but better yet, in every tree that you see, there's always a hole in the middle. For some reason, there is always a hole in the middle. I never understood why. So the way I look at this is this. So think of the fraction line as the grass, right? There's things going on under the grass or beneath the grass, and there's things going on above the grass, okay? If you look beneath the grass, what grows? Roots, right? And what is usually above the grass? Well, above the grass, typically you have a sun. And the sun gives us power. And vitamin D, of course. So obviously we're gonna have, that's why people like to go out and get some sun, because it puts a smile on their face, because it gives them power. Okay, yep, there I am next to the tree with the hole. It's wonderful. And of course you're gonna have, some seagulls flying, So again, above the ground, we're gonna have the sun, which gives us power. So that's above the grass. And below the grass is where the roots grow. So if you compare those, that's where those are coming from, okay? So again, let's look at it this way. So this right here is what we call the root, right? And hence, we're going to call that also the root. All right, so the root goes underneath, and the power whoopsies. Something happened here. fix this here. There we go. All right, that looks better. Okay, so again, that's where the power goes above, the root goes underneath. All right, and I know you love my wonderful picture there, and that's how artistic I am, aka not very artistic at all. Now, you guys do remember your exponent rules. So because we're changing everything to rational exponents, we're going to have to bring all the exponent rules back. So for example, you have, if they have x to the a times x to the b, that's x to the a plus b, right? You have, if I have x to the a divided by x to the b, that's equal to x to the a minus b, right? And also, if I have x to the a raised to the b power, that would be x to the a times b, okay? So you guys are gonna have to remember those rules and bring those rules back again. So just be careful with that, all right? So let's do a couple more examples of this here, and then we'll get into where it becomes more difficult, all right? So here we go. Let me see here. If I said the fifth root of x to the 10th, okay, that would equal to x raised to the 10 over 5, because the 10 is the power and the 5 is the root. So let's do this here. So this right here is the root. And so therefore this right here would also be the root, okay? But if you notice, I can simplify that fraction, so therefore this is x to the second power, or x squared, all right? All right, so what kind of problems are we gonna see that's gonna be difficult? So I'm gonna do two problems that are going to look the same, and you're gonna be kind of confused, but there's a reason behind those two problems, and here is what I'm gonna show you. So let's say I give you a problem that's x to the 5 over 6 divided by x to the 3/5. Well, since I'm dividing, this is x to the 5 over 6 minus 3 over 5, okay? So in order for me to do this, I need common denominators. So let me rewrite this here. 5 over 6 minus 3 over 5. And my LCD is a 30, so I need a 6 here. If I do it to the bottom, I got to do it to the top. This I got to multiply by 5, and if I do that to the bottom, I got to do it to the top. So now I have x to the 25 over 30 minus 18 over 30. So my result is x to the 7 over 30. And there's my answer, okay? So that's how you do rational exponent problems. However, the issue is going to be this. Let's say you're given a problem that says, okay, I want you to divide the 6th root of x to the 5th that work too, divided by the 5th root of x to the 3rd. Okay, so now if I come back up here, I said to you that in order for this to happen, the root or the index has to be the same. So with that being said, I can't divide these two because the roots aren't the same. So what do I have to do? How do I do this type of problem? So the way I have to do this type of problem is that I will have to change these radicals to rational exponents. So let me write it this way. In order to do this problem, if I can spell, that'd be awesome. Need to change to rational exponent. Okay, so what does the rational exponent look like? It's going to look like x to the, what's the power? 5. What's the root? 6. Over x to the, what's the power? 3. What's the root? 5. Wait a minute, that looks familiar. Doesn't it look like that type of problem right there? So I already know that this is equal to, so again, I'll bring it down. So I know I have to do x to the 5 over 6 minus 3 over 5. Okay, so let's bring it down here. So I have, this is going to turn out to be x to the 7 over 30. Okay, based on what I did up here, this is going to be 7 over 30. However, that won't be my answer. My answer is actually going to be, I would have to convert this back to a radical form because I was given, to start off the problem, I was given in radical form, so I have to bring it back to radical form. Where up here, I was given rational exponent form. That's the reason why I would give it back in rational exponent form. Okay, so I want you guys to understand that. Where here, because I was given it in radical form, I have to give it back in radical form. Okay, so how does this convert to it? So what's my power? And what's my root? Now that would be my answer for this question. Okay, see the difference? Start out rational exponents, give it back to rational exponents. Start off with radical, end as a radical. All right. So the biggest mistake that people make is if I gave you the square root of x to the 5th. This is where people forget about the index. So I would say this is x to the, what's the power? 5. What's the root? Actually 2, right? Remember, if there's nothing in the wedge, it's assumed to be 2. All right, so this is the notes for radicals and rational exponents. I hope you enjoy.